Economic growth is still linked to increased use of resources, causing increasing environmental pressures. This is why the European Commission has launched in 2008 a new funding scheme that supports eco-innovation. The initiative helps SMEs manufacturing with less natural resources, turning waste into valuable products and improving the environmental impacts of their economic activity. We are in Italy, a few kilometers from Modena, a region renowned for its ceramics industry. Producing tiles requires vast quantities of water and a lot of energy, and it generates a large volume of sludge contaminated with silicium carbide from the millstones. To avoid this, the company has revolutionized some of its traditional production methods. The heart of the new approach is this micro-sandblasting system. Here, compressed air projects the stone powder onto the tiles. No water, less energy. And when the abrasive material is used up, it is recycled, mixed with the tile material. This is the zero waste option.
A ipotizzare la possibilità di risparmiare in capo a un anno su produzioni di circa 500.000 metri quadrati di materiale ceramico, risparmiare anche 500 tonnellate di acqua, risparmiare circa 450-500 tonnellate di fanghi che normalmente vengono prodotte attualmente durante le lavorazioni.
Another option of bringing ecology and business together is rummaging through our bins, which are crammed with reusable materials. Here in Salzgitter, Germany, the region has numerous sorting centres. One of the centres is taking part in a debut, high-speed automated sorting of non-ferrous metals.
Die Schwierigkeit liegt darin, dass die Materialien in sehr unterschiedlichen Produkten stecken. Also wir haben Aluminium-Spraydosen. Sie kennen die Aluminium-Cola-Dose, aber wir finden eben auch Spielzeuge und jeweils in unterschiedlichen Qualitäten. Und das ist die technische Aufgabe, diese Qualitäten zu trennen.
Today, the sorters are assisted by the machine. An X-ray system and an ultra-fast camera determine the nature of the metal and whether or not it's contaminated with another material. If it is the right quality metal, a compressed air system ejects it from the stream at the end of the conveyor belt. In Decani, Slovenia, another EU-funded project demonstrates also that eco-innovation is about being inventive in order to recover final waste. The first procedure in the production of recycled paper consists in de-inking the paper. This process generates enormous quantities of sludge loaded with ink and cellulose fibre. And yet, in the eyes of Professor Likon, this paper mill sludge is a real treasure. The remaining fibres are capable of absorbing up to twice their initial volume in oily liquids.
Torej, glavni uporabniki poceni absorbentov so gotovo kemijska, naftna industrija, predvsem pa vse organizacije, ki se ukvarjajo s preprečevanjem naravnih in velikih nesreč, kot so gasilci, civilna zaščita, obalna straža.
The new absorbent is relatively easy to manufacture. Paper mills will thus be able to produce it directly, transforming their waste into a product with high added value. All over the EU there are different green entrepreneurs. These examples show that the EU can support them bringing their innovative ideas to life. Small ideas that have a positive impact and that help to turn environmental problems into business opportunities by embracing eco-innovation.
It's a problem affecting countries around the world, including India. Naman Gupta and Vishal Kanet noticed cigarette butts littering homes, yards, and streets.
This is the #1 littered item and hugely accumulated.
India's Medical Association says smokers discard 100 billion cigarette butts every year. Doctors have said for years that tobacco is the single most preventable cause of cancer. Now it's also being seen as a huge environmental hazard. The toxic butts contaminate drinking water, and they're a choking hazard for pets, birds, fish, and other wildlife.
Cigarette butts से इतना pollution हो रहा है, बाकी इतनी factories चल रही हैं.
Cigarette butts create pollution like so many factories that also pollute.
Obviously, pollution तो होता ही है सर.
People know about it but still are careless. They keep their houses clean, but they throw garbage outside.
Yeah, it's a pollution habit. We should throw it in the dustbin. That would be more proper way to dispose.
Enter the Code Initiative, a startup by these two friends. The duo researched the chemical makeup of cigarette remains and found a way to turn the debris into organic manure.
If you see from a smoker's perspective, he will say that I only smoke 5 cigarettes or maybe 10 cigarettes a day, and he's not smoking all the cigarettes at the same places. So he does not have the accountability of what the damage he is doing to the environment.
The Code Initiative has set up collection units called V-bins. The startup pays $11 for every kilogram of cigarette waste. In addition to turning waste into fertilizer, butts are also used to make packing and building materials, as well as plastics for keychains and toys.
The second thing is the employment is being generated for the cigarette vendors who are giving us the cigarette waste. We purchase the cigarette waste from them. So the amount that we give is huge for them for fulfilling their own basic needs.
The friends are enthusiastic about their new company. They're hoping to expand their services and decrease pollution one butt at a time. Paul Chadurjian, Al Jazeera.
All of the nicotine and other toxins that would otherwise seep into drains and waterways.
The entire process has been done under a study of environmental engineering, purifying 95% of the bud, so there is no problem with using them in contact with the skin.
The Butts to Clothing project began 2 years ago as Guerrero's graduate thesis. She blends the gathered fiber with sheep's wool to produce yarn, which is then used for knitting garments. For Guerrero, it is more about spreading the message about recycling than about fashion.
Como proyecto en sí, yo creo que ya es un aporte. El solo hecho de llegar a pensar que se puede reciclar algo tan pequeño es un aporte para la gente. Ahora, si yo con lo que hago aporto en el medio ambiente, son muchas las colillas y yo recojo quizá una ínfima parte. Pero si se hiciera más masivo, quizás con más apoyo, se podría lograr un cambio más significativo.
So far, the Mantis project has managed to make durable hats, gloves, sweaters, and blankets from cigarette filters. Guerrero has now patented her project and has started a small business selling items via email. All of the clothes are handmade, so she's not looking to mass produce, but she does hope the Mantis philosophy catches on around the world.
微软创始人比尔盖茨 （Bill Gates） 是世界首富，这个大家都懂。
是比尔盖茨取之社会，用之社会，将几百亿的身家捐做慈善啊，带动富豪捐身家运动，大家都耳熟能详了。
是。不过让人好奇的是，一个站在社会顶层能呼风唤雨的人呢，为什么要去喝粪便过滤出来的水？难道他不怕拉肚子吗？
一姐，我觉得我们还是说清楚一点比较好啊。事情是这样的，1月5号啊，上载到社交网的这部短片啊，目前呢已经有超过100万的点击率的，说的是一部可以在5分钟内将粪便转化为干净饮用水的机器。
Over 2.5 billion people have no access to safe sanitation. We asked brilliant engineers to help us solve this problem, and one of those engineers actually has proposed a solution where the waste is valuable.
据说这是美国西雅图一家公司研发的粪便再循环装置。简单来说呢，就是将那些回收回来的粪便放进机器里， 经过高温加热，粪便释放出水蒸气，蒸馏水再经过进一步的净化处理之后呢，就变成了可以安全饮用的水啦。
哦呦，你看这个比尔盖茨啊，哇，你看一口很有勇气的尝了一口这个粪便再循环出来的饮用水，其实我真的很好奇了，这杯水是不是真材实料啊？
管它是不是真材实料，只要不是原料那就好了哈。
幸好。
不过呢，这个短片呢也埋下了一个伏笔啊，研发机器的工程师开玩笑的说，这部复杂的机器不可能使用在那些缺乏干净水源的落后国家。
难道他们还会研发更好、更方便的污水处理装置？
最好就是这样啦，不然呢，这个引人好奇的短片就失去了它的实质意义。
But first, in the UK, we throw away billions of plastic bottles every year. We're getting much better at recycling them, but did you know that they can also be turned into clothing? This amazing process starts here at the Bottle Recycling Centre. The first stage is shredding. When you throw away your bottle, you often leave a small amount of drink inside. Shredding all the bottles releases the unwanted liquid so it doesn't affect the quality of the plastic. The shredded bottles are then wrapped in cellophane and boxed up ready to be shipped around the world. It may be rubbish to us, but to the Chinese textile industry, this plastic waste is a valuable commodity. Recycled bottles arrive from all over the world to feed the busy clothing industry. Sorting separates the clear plastic from the coloured stuff. Clear plastic can be made into white clothes or material that can be dyed, so it's extremely valuable. Most clear plastic bottles have coloured lids and stickers on them, but these have got to go, so the bottles head for the baths. The coloured caps are made of a different plastic which floats. A worker can then strain them off the top. Then there's a separate bath for the stickers, but the workers have to be careful around this one. It's corrosive caustic soda, very bad for the skin, but very good for removing labels. After all their swimming, what's left is a pile of clear plastic shreds. But it's rather wet. The next step is the ovens, where it's mixed with some light-coloured plastics. To produce white cloth, you need some light-shaded material in the mix. The plastic will spend about 10 hours here in these rotating drums, slowly drying out. These workers have to maneuver their cart back and forth underneath the drums to catch the plastic as it falls out. But they've also got to mind their heads on all the other spinning ovens. So we've got our plastic bottles broken down and mixed to produce the right colours. But it's very hard to weave cloth from bits and pieces, so another step is needed. The mixture is sent through this rotating screw where it's heated to 270 degrees Celsius. This melts the plastic, but to make cloth we don't want a big lump, we need thread. The liquid plastic is forced through a sieve and emerges on the other side as great long strings which are collected in a container below. We've now got thread, but it isn't strong enough to make cloth yet. First it must be combined and stretched several times while being heated. This will bond the fibres together. Now it's taken ages to produce this material, but the next part of the process is to tear it apart again. The fluff that emerges is the raw substance you need to make polyester. However, that takes place in another factory altogether, so the workers here bale it up and send it on. It looks like cotton wool, but it's an entirely man-made substance created from your old bottles. This machine scrapes it all onto a very rough cloth which is loaded here, ready to be carded. Carding is where the bonded fibres are brushed together so they all lie in a similar direction, which strengthens the material. The sheet of polyester felt that emerges is now ready to be turned into thread. These machines will tease it out. They spin off mile after mile of pure polyester, which is collected on these bobbins. And finally, we reach the point where your old plastic bottles become cloth. Like a spider at the center of its web, the loom draws in thousands of threads and weaves a new sheet of polyester. To give it a smoother feel, there are still 2 more processes to go through. The first is very delicate. This machine creates tiny loops on its surface. The second stage is the opposite. Using a series of tough steel brushes, these spinning rollers catch and tear all the carefully made loops. The shredded surface helps give the material a soft, furry feel, making it far more comfortable to the touch. So we've turned our recycled bottles into polyester at last. Now it's time to make some clothes. Using a roll of material, stylists mark out the latest designs, being as economical as they can with their handy template. Although they're profiting from your rubbish, they don't want to create any more waste. The pieces will then be sent to workers who turn your trash into the trendiest gear you can find on the high street. So what started out as your rubbish was carefully sorted, then shredded and turned into cloth. That cloth was shredded into fluff, spun into thread and turned into fashion, from plastic bottles to polyester clothing.
Hello and welcome to Business Planet in the Croatian city of Zagreb. As Croatia joins the European Union, we're here to talk about eco-innovation. It's a real opportunity for entrepreneurs. Eco-businesses employ a total of 3.4 million people across Europe. It has to be said that SMEs, especially here in Croatia, are brimming with ideas. Let's take a look.
These noise barriers being built along the motorway near Zagreb are a concentrate of innovation. They're made up of 40% of recycled tyres and are among the most efficient on the market. They are the result of a project launched in 2009 as part of the European Eco-Innovation Programme. One of the companies involved in their production is a business which recycles tyres, turning them into a powder used to make the barriers. It's a great opportunity for innovation.
If we achieve the goals that were set, we're hoping to hire up to 30 people and double our production capacity.
The powder is mixed with cement in this other factory where the noise barriers are moulded. Here too, it's hoped the project will help hire an extra 60 people.
It's opened up new doors. We're hoping to increase turnover by 25% in Croatia, but also in neighbouring countries.
It's a serious investment. Danica Jelenic put in €355,000. She's delighted with the result.
Taking part in this project has really strengthened our position. We're taken seriously by other players on the market.
The European Eco-Innovation Programme gives access to subsidies that will help launch a project. To this day, it's benefited 200 projects throughout Europe.
The noise barrier project was born here at Zagreb University. It's the brainchild of Professor Stjepan Lakušić. Half of the project was funded by the Eco-Innovation Programme, which provided €500,000. The plan is to sell the technology to neighbouring countries, always in need of recycling tyres.
You need 65 tons of recycled tyres to produce a kilometre-long barrier that's 1 metre high. That's 8,000 old tyres.
This new technology has already attracted a number of potential buyers, seduced by the low production cost.
Using recycled products brings down the cost by 10 to 18% compared to similar products on the market. For me, the keys to success are, first of all, developing products from recycled material, human investment and new technologies.